All right, boys and girls, welcome, welcome, welcome. This is an unexpected video, unexpected assignment, but I feel like this assignment will best prepare you for the upcoming test. It's mirrored very closely to the test questions themselves. The reason that this is kind of new is I just created this assignment, um, again, to better mirror the test. And the reason for that is I don't feel that during this chapter we taught continuity very well. And continuity is actually a major part of the test. So I'm trying to lead you into what questions are going to be asked. So with your minimal knowledge of continuity and the continuity test, you can still be successful. So before I actually get to this, let me remind you of the continuity test itself. So what is the continuity test? Okay, how do you tell if something is continuous? All right, so it's broken down into three major pieces. However, it could easily be five. All right, the first thing that you want to do is you want to test your limits as x goes to some number from the left-hand side, and we're looking to get a number out of that. And we're also looking to get the limit as it goes to the right-hand side. And what we're looking is that these two answers are the same. Okay, so the left-hand limit is equal to the right-hand limit. So if the left-hand limit is equal to the right-hand limit, as described here, that implies that the limit itself exists and is that constant. All right, so let me kind of put a big dot in this one, okay? So things that won't have the limit. So does the limit exist? Does the limit exist? That is very dependent upon these answers to the left and the right. The answers to the left and the right. So the left and the right have to be the same thing, and they actually have to be a number. So they can't be infinity or does not exist or something like that. They straight up have to be a number itself. Okay? So if they are equal to numbers and the numbers are the same, that means the limit exists. However, if, like, let's say that this number is, this number is 5 and this number is 2, then this limit does not exist. So the limits have to be equal to each other and they have to be equal to the same thing. All right. So the limit exists. Okay. Next, the point itself at whatever we're taking the limit at has to be equal to something. So the big picture items is one, the limit has to exist. All right, and how do I tell if it exists? Well, you take the limit to the left and the right. Two, the point itself exists. Okay, the point itself, the actual concrete point exists. Now, the third and the big final stipulation of the continuity test is that the limit is equal to the point. Okay, the limit is equal to the point. So is the limit as x goes to c is equal to the actual f of c. And what I do when they are equal, then I write a little final statement that says, thus, f is continuous at x is equal to, in this case, c. Right? So you make a little fine statement. Don't assume that the reader knows what that means, okay? So because they are equal, thus f is continuous. If they are not equal, then you would say thus f is not continuous. That sort of idea. So they have to be equal. So let me put that into my red writing over here. The limit has to equal the point. Okay, that is the continuity test. That is the continuity test right there. Let's see if I can come up with a quick example. Let's say that I have an f of x that is the, oh shoot, no, actually the first examples of the practice test I think cover this. Okay, so let's get right into it. Show with evidence that f of x is or is not continuous. Okay, at x is equal to 1. All right, so what we're going to do is I'm going to test my limits. So my limit as x goes to 1 from the negative. So 1 from the negative is where x is less than 1. So what I do is I plug and chug 1 into that. So that's going to be 1, 2 squared plus 1. So that's 3, 9, -9, -8. So the limit is equal to -8 from the left. Going to go from 1 from the positive. So from the positive, it's where it's bigger than 1. So it's going to be that top equation. And so that's 1 minus 3 to the third. And so that's -2. -2 to the third is -8. And so far, so good. So because these two limits are the same, one-sided limits, because they're the same, that implies that the limit as x goes to 1 is equal to -8. So the limit exists. That's a big chunk out of our test there. Oops. Okay. So the limit exists. Next thing that we have to do is we have to show that the point itself exists. So that f of 1, so that's where it's or equal to. So that would be 1 minus 3 to the third, which is equal to -8. Okay, so the limit exists and the point exists. So the limit and the point exist. All that's left is to wrap up this problem by saying, what I notice is that the limit as x goes to 1 is equal to f of 1. So the limit is equal to the point. Thus, f is continuous at x is equal to 1. So this is continuous. And so what you have to show when you do this problem is, because the partial limits are not obvious, you have to show all 5 parts. You have to show all 5 parts. Right? You have to show all 5 parts in this case. Parts that you must show all the time, no matter what, is 3, 4, and 5. 3, 4, and 5. Regardless, if you know that it's discontinuous right away, you got to do 3, 4, and 5. 1 and 2 you can skip every once in a while. Like if the partial limits, the one-sided limits are obvious. Like in number 2, and I'll show you why it's obvious in number 2. You can skip that part. Okay, number 2, show with evidence that g of x is or is not. All right, now think about this. If I take the limit as x goes to 2 from the negative and the limit as x goes to 2 from the positive, what equation am I referring to? Okay, so we're talking about something that is not a 2. It's going towards 2, but it's not 2. So what you're doing is you're implying that you're using the same equation for both. For both of these situations, you're using x minus 3 squared. All right? So here, you don't have to show the partial limit. The partial limits are just a waste of time. You can go right to the limit itself. So these are obviously going to be equal to the same thing when you plug in a 2 into that equation. You're obviously going to get the same answer. So you can skip the partial limits in this situation. However, when the partial limits are 2 separate equations, like in number 1, you have to go through the partial limits. You have to go through the one-sided limits in those. All right, so here, we can just kind of jump into it and say, what is it when x goes to 2? G of x, not f of x. And so that is going to be 2 minus 3 squared, so that's negative 1 squared. That's going to be positive 1. That's positive 1. So we have the limit. Now we have to go to the point. What is g of 2? And that is when x is equal to 2, and that's straight up equal to negative 1. So I have the limit, I have the point. Now I have to make that determination, and what do I notice? I notice that the limit as x goes to 2 is not equal to g of 2. Okay, the limit is not equal to the point. Thus, g is not continuous at x is equal to 2. So again, what the continuity test is, let me back up just one more time. The limit must exist. The point must exist. And the limit has to be equal to the point. The limit must exist, the point must exist, and the limit must be equal to the point. All right, number 3, we say that it is continuous. All right, so it is continuous. So that means the limit as x goes to 2, excuse me, let's start with the negative 2. That means that the limit as x goes to negative 2 from the negative is going to be equal to limit as x goes to negative 2 from the positive. Okay, that means that is absolutely true. So let's start with that concept. What is the limit as x goes to negative 2 from the negative? So look at negative 2, but smaller than negative 2. So it's that very top equation. So that implies that that's negative 2 to the third. That's going to be equal to when x is a little bit bigger than negative 2. So that's that middle equation. And so that would be ax plus b. So right now, we just said negative 8 is equal to negative 2a plus b. Okay, so the limit has to hold. The limit has to hold at negative 2. And so what I'm, in essence, saying is, back to the continuity test, that number 1 and number 2 are satisfied. Number 1 and number 2 are satisfied in this picture right here. As in, the left-hand limit is going to be equal to the right-hand limit. That you know that because it already said that it is continuous. So the limit left has to be equal to the limit right. Okay, so that's what that's how I'm starting that problem. So I just said limit left and limit right are hold at negative 2. Also, it will hold at positive 2 because it's negative 2 and positive 2. So this is saying that the limit as x goes to 2 from the negative is going to be equal to the limit as x goes to 2 from the positive, right? So 2 from the negative, again, is that middle equation. However, this time the x is actually a positive 2. So that'd be ax plus b. And that's going to be equal to 2 from the positive. And that is 3x minus 8. 6 minus 8 is negative 2. So this is 2a plus b. All right, so now I have 2 equations, 2 unknowns. So all I have to do is just kind of do some math stuff. So I'll work with the blue here, and I will solve for b. So b is equal to negative 2a minus 2. Okay, I'll work over there. So I got a b. So that means jumping over to the red, that negative 8 is equal to negative 2a plus negative 2a minus 2. So this will be negative 4a minus 2 is equal to negative 8, negative 6, negative 4a. A is equal to 3 over 2. Plug that back over into my b equation. And so thus b is going to be equal to negative 2a, which is 3 over 2, minus 2. So this is going to be what? Negative 3 minus 2 is negative 5. Thus a is equal to 3 over 2. B is equal to negative 5. Okay, this is asking for where is removable discontinuities, vertical asymptotes, things like that. Removable and discontinuities and vertical asymptotes are bottom zeros. So what we're really asked to do is factor the junk out of this and then figure stuff out. So I see that I can GCF out of 2x x, something like that. So this will be a 2x, x plus 2, x plus 3, with an x plus 1, x minus 1. All right. So, right now, I see that x cannot be equal to 0, negative 2, or negative 3. Those are off limits. However, which one are vertical asymptotes, which one are removable discontinuities? And so I can see that I can cancel that. All right, so that indicates that that is a removable discontinuity and that these two are vertical asymptotes. So if you can remove it, it is a removable discontinuity. Okay, it's still not in the domain. You still can't make x equal to 0, but it will be a hole in the graph as opposed to like a vertical asymptote. Okay, list all the question A. List all the removable discontinuities. X is equal to 0 is a removable discontinuity. List all the vertical asymptotes. That would be x is equal to negative 2 and x is equal to negative 3. Those are the vertical asymptotes. And then what is the domain of G? Well, it's all real numbers except for 0, negative 2, and negative 3. They're all off limits. That's it. Next, they're asking for a list all the horizontal asymptotes. What a horizontal asymptote is determined by is if you take the limit as x goes to infinity or negative infinity. Infinity and negative infinity, I should say. And what you get to do when you take it to infinity is you get to ignore all of the small exponents, so you only keep the largest, and then you simplify. And so I am left with in essence, a 1 over a 2. List all the horizontal asymptotes. Y is equal to 1 over 2 is a horizontal asymptote. What's the range? Everything except for that 1/2. Now that isn't always true. An asymptote doesn't mean that it's off limits, but it is in this case. Okay, and then now we have just a bunch of limit problems. And so some of these use some of the weird rules that we probably haven't seen in a while. So pay attention to these. These are all written directly as a result of what the test questions are. So know how to do these. All right, so we have 16 plus x plus 4. What I'm going to have to do here is I'm going to have to multiply by the conjugate of this. So it's going to be the same stuff, but a plus 4. So what occurs here is I'm in essence squaring this top. So square, square, the square root goes away. So this is the limit as x goes to 0. So the square root itself goes away. So that's going to be 16 plus x. Then it's going to be a plus 4 square root, a minus 4 square root, and then a minus 16. And then this is going to be x, the original denominator, and then the 16 plus x plus 4. Okay, so what do I see here? I see 16 minus 16, isolating the x, and then I have an x divided by x. And now it's totally good. I can plug in a 0, so this is 1 over. Plugging in a 0, that would leave the root of 16, which is 4. 4 plus 4 is 8. All right, for number 6, I can't plug in the 3, so try to factor. So this is the limit as x goes to 3 from the positive of x plus 3, x minus 3, all over x plus 3. So we see that the plus 3's drop. Now I still can't plug in that 3, but we're forced into it now. And so what would happen if I go from a 3 plus, that's a little bit bigger than 3, that denominator is still going to remain positive. Okay, that denominator is going to remain positive in that situation. All right, number 7. Here's one where this is going to use a couple different things, and I'll point them out as I go along. With this, you can't just plug in the 0. You got to work with this somehow. And what you're going to do is kind of similar to number 5. You're going to multiply by the conjugate of that numerator. So that's 1 plus the cosine. All right, so again, what will happen is 1 times 1 is going to be equal to 1. Then I'm going to have a positive cosine, a negative cosine, so they add and subtract each other. And then I have a cosine times a cosine, but a negative times a positive, so that'll be a negative cosine squared. All right, this is a trig identity. This is a trig identity. This stems from the idea that sine squared plus cosine squared is equal to 1. Thus, just manipulating this, just subtracting a cosine squared from both sides, in essence. Okay, subtracting a cosine squared from both sides, that means sine squared is equal to 1 minus cosine squared. Right? That's the trig identity right here. So This is the limit as x goes to 0 of sine squared over 4x squared. All right, so there's one more leap right there. All right, now what we are going to use now, it was in one of the assignments, I know it for sure. There was a limit as x goes to 0 of sine x over x. It's one of those things that I just said I wish I had a better explanation, but you just kind of have to memorize it. That's equal to 1. Sine x over x when limit as x goes to 0 is equal to 1. Okay, so that's what I'm going to do, and I'm going to just break apart this fraction into all of its pieces. So this is in essence saying limit as x goes to 0. Sine squared is just sine times sine. That's what sine squared is. 4x squared is the same thing as saying x times 4. Okay, so the numerator is sine squared, the denominator is x squared, or 4x squared. All right, so what I see, now I can take this limit, so this is going to be 1 times 1/4. So there's some trig stuff in there, so again, I do apologize for that, but it is what it is. All right, as x goes to 3, here I can actually just plug and chug it. There's no illegal mathematics. This is what, 0 over 18, so that's 0. There's no denominator of 0. It's okay. It's okay to be 0. Here, as I go to infinity, so I get to cancel out anything that isn't those, in essence, x squareds. Simplify, and so this is what, -1, because that is a negative x squared over a positive x squared. That's -1. Okay, limit as x goes to 2. Yeah, so I actually have to kind of work with this. This denominator is x plus 1 minus 2. This numerator is close to that x minus 2, but it's in the wrong order. So what I'm going to do is I'm going to take out a -1, and that changes the order of the subtraction. So I see that they drop now. Now it's totally possible to put in that 2. And so that is what? -1/3. Here, just simplify. Okay, x's drop, and so this is equal to 2/3. Simplify. X goes to -infinity, so again, infinity rules hold. These cancel to 1. You know, x to the 3rd over x to the 3rd is equal to 1. Again, this is going to utilize the idea of sine x over x. However, in this case, so the limit has to go to 0. And then the idea is whatever numbers are here, like with the x, so sine 2x over 3x or something like that. The sine x over x goes to 1, and what will remain is the coefficients of those x's, coefficients of the x's. So again, it's just one of those things. Like, I'll explain it when we learn about L'Hopital's rule, but until that point, just it's one of those things that you just kind of want to memorize. And so this is straight out of 3 over 2. Number 14, going to an infinity, so I cancel anything. So in essence, this is a 2x to the 3rd over a 6x squared. Simplifying this, I see x squared takes out two of these and 1/3 doesn't really matter because this is going to be an x over 3. Putting in an infinity, that is equal to infinity. Same idea as before. The 1 minus cosine is kind of a tip off that you're going to be dealing with probably a sine squared. And so what I'm going to do is I'm going to multiply by 1 plus cosine. And so this is going to be 1 minus cosine squared. And then this is x sine x and 1 plus cosine squared, or excuse me, 1 plus cosine. The trig identity of the numerator is that is a sine squared. Going to start a new line here. I'm running out of room. So this is limit as x goes to 0 of denominator as x sine x and 1 plus cosine x. And the numerator is the trig identity of sine squared. Okay, so I see one obvious cancellation right here. A sine is going to eliminate one of those sines. And what I have left is, in essence, again, I'll start one more line. I have sine x over x, so that's going to be 1 times 1 plus cosine x on the denominator. So what this is going to be, sine x over x is 1, and then putting in a 0, I see that the cosine is equal to 1. So this is going to be 1 over 2, plus this is equal to 1/2. Okay, man, they love the sine x stuff. All right, so here I can GCF out an x on the denominator. Okay, so I have a sine x over x, which is equal to 1 times, in essence, a negative 1/4. Okay, in case you didn't see what I did here is I went sine x over x times 1 over x minus 4, and then plugged in the 0, so this is 1, and 0, this would be negative 1/4. That's what I did. Limit as x goes to 3, well, that's 0. You can just plug and chug. No illegal mathematics. It's okay to get answers of 0. Just because you get an answer of 0 doesn't mean it. Bottom zeros are a different story, but you can get zeros. Where is the function discontinuous? That would be bottom zeros. Easy peasy. You don't have to do any work. It could drop or whatever, but just because it drops like it does here, okay, just because it drops doesn't make it continuous. Just because it drops doesn't make it continuous. Discontinuous are bottom zeros no matter what. Whether it be a removable discontinuity or a vertical asymptote, it's still discontinuous. Which of the following functions is not continuous everywhere? So again, is it possible to get bad mathematics? All right, so if you square a number, that number is always going to be positive or 0. All right, it's always going to be positive. So there is no possible way for x squared to be negative 1. So that one's good to go. This one is continuous everywhere. Okay, absolute value is continuous everywhere. Uh-oh. I can make an x a -6 in that case, making a denominator 0. So that is discontinuous. Looking for inside negatives, but again, that number is always going to be positive. Always going to be positive. If you square something, it's always going to be positive. So there is no possible way that I can get a negative exponent on that inside. Or excuse me, a negative number on that inside. So that one's good to go. To the 4/3, that just means it's a cube root of some sort. All right, that's good to go. There isn't anything bad with that, and fun. And then a sign is always in between 1 and 0, or excuse me, -1 and 1. This is always between -1 and 1. But regardless, I'm not creating any illegal mathematics. I'm not, creating a denominator of 0 or anything like that. So the only function that is not continuous everywhere is that C option. From the function, identify all the vertical and horizontal asymptotes. So verticals are bottoms that don't drop. So let's factor this. So the numerator is x plus 1 minus 1. And the denominator is 2 plus x minus x. So bottom zeros would be x is equal to, excuse me, nothing drops. Notice that nothing drops. So all the bottoms are vertical asymptotes. Vertical asymptotes would be at x is equal to -2 and x is equal to +2. Okay, that would create bottom zeros. Horizontal asymptotes are when the limits go to infinity. And so when the limit goes to infinity, that would be a horizontal asymptote at -1. X squared over -x squared. It simplifies to -1. I should probably write that as an equation. The horizontal one. Okay, last but not least, I think they just ask us to break apart this piecewise function into these various limits. So x is equal to 2, that would be that equation right there. And so that would be 3 times 2 minus 5. And so that is equal to 1. Let's go to B. X is equal to 0 from the positive. So again, that is where x is bigger than 0. So that would be that equation there. So that would be 3, 0 plus 5. So that's the limit from 0 from the plus side. Question C, -3. -3 is obviously where x is less than 0. So that would be 2, -3 minus 1, so this is -7. And last but not least is what is it when 0 from the negative side? So that is when it's a little smaller than 0. That's obviously that top one right there. So that's 2 times 0 minus 1. So this is equal to -1. Okay, that's it. So if you are able to answer these questions, you are in good shape for the test. So as I said, what some people may need to look at is this continuity test. This is really important, the continuity test, as well as the idea of sine x over x. Yeah, this problem right here is a good example. So you have this trig identity of 1 minus cosine squared is sine squared, and you also know that sine x over x when x goes to 0 is going to be equal to 1. All right. So if you know number 15 and you know the continuity test, you're doing pretty decent. Again, these questions are almost exactly what the test questions are. So give this one a good go. If you stumble, watch the video again and try to pick it up. All right. Have a good day, everybody. Keep smiling. Keep smiling.